we now move on to the question and answer portion of this webinar. As such, I would like to invite all of our speakers, David, Benjamin, Luzen, to join me as we address the questions from the audience.
Hello, Stefan.
Hello, Luzen. Hi, Benjamin, and hi, David. Thank you very much for joining us today. Yes, so it was a great presentation despite the technical issue earlier on, but the show must go on. So far, we have quite a bit of questions from our audience. Okay, first things first, I think this one is from Dagmar. And I think this question may be directed to Siemens as well as SLM maybe. But first, okay, for Benjamin, which key industries do you address?
I think additive, that's a really good question. I think additive manufacturing as a whole goes across a lot of industries. Today, we have been focused on aerospace and shipping and marine. Obviously, we have a lot more interest in medical at the moment because that's where the core of getting PPEs and ventilators have been coming to us. We also address the general manufacturing because 3D printing is not just for the end product, but also as jigs and fixtures that support the production line efficiency. So I would say additive manufacturing is an enabling technology that goes across all industries, not anyone in particular, yeah.
All right, maybe Luzen, you can share your insights on that as well.
Yeah, I think just to add on, so basically I think all the industry mentioned by Benjamin just now are also heavily used by SLM or metal AM. I think just one more example will be molding and the tooling. We do see, especially in Asia, both Southeast Asia and China, lots of AM adopters, they are heavily trying using AM for developing new molds or inverts for the tooling and the molding industries. So I would say that will be the add-on besides aerospace, medical, oil and gas, yeah, these common industries, yeah.
All right, thank you very much for that, for your answers, gentlemen. Next, I believe this will also be relevant to you guys, Luzen and Ben. Do you have any simulation technology related to 3D printing?
Yeah, we do. So in Siemens, we are one of the top 10 industrial software solution providers. We do a lot of design work using our NXCAM suite of solutions. We do the design work, we do the simulation, and we have included a generative design as well to help the designers improve their design and sort of add in additive manufacturing techniques, lattice structures and support structures, as well as compensate for leans. So I think we do have that simulation package, and we have a strong focus on what we call the digital twin, where we have the virtual commissioning of the product, the assembly, and the entire factory. So it helps customers really have a faster speed to decision making and really have a product that is first time right.
All right, maybe Luzen?
Yeah, ourselves, SLM, we do not have our own software, but we do like try and trial with all the available software available in the world. And after all the experience, we try to also convey our experience and knowledge to our customers. And we can give some advice for them, maybe which one is better for your case. Because I think there are softwares dedicated for some applications or for some industries. So we are actually like the middleman. We try all the software first, and then we can coach or advise our customers accordingly. Yeah, thank you.
All right. Okay, this next question, I believe the three of you can answer. So maybe we can ask David first. David, one of the question is, do you see AM or additive manufacturing one day being used for mass production?
Yes, definitely. I'm sure that's the case. It's a gradual process, and we're seeing new innovations every year. We're seeing them in materials. I think for 2021 we'll see sort of new software, new processes, new engineering sort of software. It's not going to happen overnight. But I think in 2020 we've seen the importance of 3D printing, additive manufacturing, in a number of different areas, particularly in sort of things like healthcare and medical areas. So I think over the next sort of 2-3 years, we will see a huge increase in the value and the importance of the additive manufacturing sector.
What about you, Benjamin? What do you think on this on this question? Do you see being used for mass production?
Oh, definitely. I think at Siemens, we are the first adopters of additive manufacturing in a serial production environment. Our energy division, today, they're producing about 2,000 parts in 3D printed parts for the gas turbines. So we are first adopters for serial production, and we're supporting industries in the UK, the Formula One cars and the aerospace companies to develop stuff. So I think we are bridging that. We're trying to bridge that in Asia specifically. I think the level of adoption in the US and Europe is actually quite high. So one of the purposes for us in setting up this AMTC, Advanced Manufacturing Transformation Center, is to enable the bridging of the gap. Yeah, we want to teach customers how to fish, thereby generating that demand, and eventually the supply market will follow.
All right. What about you, Lucien? Anything to add?
Yeah, we do have quite a few customers in both Singapore and the Malaysia or other Southeast Asia region. Like they are running machine 24 hours a day and 7 days a week. Like basically they are running the machines day to day for, but I won't say mass production yet, but in large scale and with the same design. But I do believe in the future with more machines and with more digitalization of the whole manufacturing production chain, they can achieve the final mass production stage. Just like it takes some time for both the machine side to be ready and for the customer to fully understand and implement the mass production solutions. Yeah, thank you.
Stephen,
all right.
Stephen, I wondered if I could add. I could ask Benjamin, because I've been doing some work around writing about digital twins, and it's very interesting hearing you mention the use of digital twins. I think it's the use of those sort of technologies that will be really sort of useful in driving success forward. You know, over the next sort of 2 or 3 years. So I wonder if you've got any more insight into, you know, how you've adopted sort of digital twins. Obviously, you know, it's a big part from your company, but I was just interested to hear you mentioning it. You know.
Yeah, but I guess it's a nice cycle for us. So we have the software teams developing the NX CAD design. We have the end users in the Siemens Energy team doing the actual manufacturing. So whenever we collect the data set goes back into the software team to enhance the software. So now simulations are moving towards more a realistic platform. So the virtual twin mimics the actual real life occurrences. So we have certification bodies beginning to accept some of the simulation results that we have in our tools, and they are doing what we call virtual commissioning. So pre-certification of parts that are designed on our tools to have the preliminary acceptance. And that's what we're doing with aerospace customers today. Yeah. So rather than building the full thing and going through expensive destructive tests, the first stage is the virtual commissioning of the product.
And ultimately, that sort of thing helps from a long-term point of view, doesn't it? In terms of the production question we just had.
That's right. I think the biggest part in AM today is confidence in the whole manufacturing technology. Certification provides that initial bridge, but I think the acceptance needs to be more far and wide, where additive manufacturing should be seen as just any other manufacturing technology. Yeah, it's just a little bit unfamiliar grounds for a lot of the people. But once you get used to it, once you adopt it, it becomes quite an addictive technology, if I must say. Yeah.
All right. And I think this question from Sim is directed to Benjamin, as you demonstrated the face shield earlier on. So his question is it more productive to use injection molding for the face shield?
Yeah, in this case, injection molding will be cheaper, I would say, but the injection molding startup is expensive. But I think what we've seen from the facial design is something that injection molding can't do. The PA material, when soaked with the special coating that we have, enhance the whole flexibility of the product. Yeah, so you can actually stretch the face shields, yeah, to a really extreme end without breaking. Unlike injection molding, it will have fractured. So additive manufacturing has its own benefits, and I think understanding the full technology before going to discussions about cost is important. So I think in this case, what we realized from additive manufacturing using the MGF, I think the whole flexibility using the coating has really improved the whole quality of it, and it fits all different sizes. So it's not about whether injection molding is more productive or not. It's a totally different quality.
All right. And then, in related to that question, do you have any difficulty to get the supply of material base?
It's always a supply and demand question. Yeah, a lot of the powder manufacturers that we work today with ask us, what is the demand? You know, how much supply should I bring in? Is there enough demand for me to supply? And then what we are doing here at AMTC is really to help the industry or the big MNCs really take on the adoption and sort of drive the supply chain to fulfill that need. Yeah, so here at AMTC, we have a full range of technology partners for metal printers and polymer printers and metal jet binders, as well as post-processing equipments, along with advanced manufacturing like AGVs and drones. So we want customers to come here not only to learn, but also do it themselves. We want to teach them how to fish. And that's the only way this multiplier effect will happen. And the whole adoption curve will sort of accelerate from there.
All right. Maybe I can get Lucen's insights on that as well regarding the supply of material base for AM.
Yeah, I think right now we do have quite a wide range of metal powder supplier across the world, especially in Europe and the USA. And we do see there is emerging powder suppliers in Asia, even locally or in China. So I think eventually it's about the qualification of the powder quality, whether with a new supplier, can they really print the same good quality parts. So it takes some time for testing. So I would say it's not hard to get a supplier, but it may take some time, especially you need to do all the quality assurance on a new powder supplier. So I would say it depends. It's really up to what's your requirement on your part. If it's a very rigorous or stringent requirement for aerospace or medical, yeah, it may be hard. But if you are more for general parts or applications, it may not be so hard because there are actually quite a bundle of suppliers, even in Asia itself. Yeah, thank you.
All right. And then we have another question sent by Kulkarni through the ask question portion of the right-hand panel, as I was explaining earlier during the presentations at the start. So his question is, what are the best ways service bureaus can market themselves to attract AM enthusiasts or clients? Maybe Benjamin, can you answer that first?
Well, I think a lot of services bureaus struggle in the sense that they have to have a wide repertoire of technologies. Yeah, and the realm of polymers and metals and the type of printing SLA is so far and wide. It's difficult for services bureau to really hit the nail on the head when customers say, I need a particular part printed in metal, for example, and he carries a polymer printer. So that is always difficult. We've seen a lot of services bureaus struggle in terms of lack of demand. How they can really encourage more usage is really for the OEMs themselves to really drive the adoption of their technology, before they actually end up with the services bureau. So very close working relationship with the OEMs is quite key, as well as the designers of these products, in order for them to adopt a certain area of technology, because you can't have powder metal bed and then polymer together. You need to have your AM strategy correct in order to have economies of scale.
All right. Do you have anything to add to that, Lucen?
Yeah, I think just one quick point, follow up with Benjamin. Yeah, so I think for the service bureau, it's very both sometimes when customer give a part, it may not be designed for AM yet. It may be an old design or conventional design. So it's very important for the service bureau to educate the customer how you can change the design to better suit for AM, and then they can actually even save the cost or improve the productivity. And I think by doing so, it also helps the service bureau to attract these customers to really adopt their solution. And eventually, yeah, it can be a positive relationship between the customer and the service bureau.
All right. I have another question here. I think David can answer this. On balance, despite the problems the pandemic has caused, how has 3D printing benefited from the coronavirus exposure?
Well, I think the biggest thing is mainly the visibility of 3D printing that we've seen throughout the year, and I think that will perhaps drive more interest from a medical applications perspective. I think healthcare now, as we've all seen, is such a sort of vital industry, and I think we'll see more interest in there where there'll be an opportunity for 3D printing. I think 2020 has been a lost year you know, for most industries. And I think we'll see renewed interest across the piece in 2021. I think 2021 will be quite a competitive year. There's lots of sort of organizations that have been financially sort of challenged. So I think there'll be a lot of impetus going into 2021, simply caused by the fact that, you know, everything's been on hold in 2020. And I think 3D printing will be at the heart of that. I think we've seen from the issues across supply chains how important 3D printing is going to be in the future across all industries. So I think there'll be a lot of pent-up demand, and we'll see a really interesting 2021.
All right. We have another question from you here. So this is about post-processing. So how can you improve the strength of the product by maybe by means of porosity, in terms of removal of porosity? Yeah. Which software do you use? Maybe Benjamin, you can address that, and then Luzen next.
Well, we don't have a software for post-processing specifically. I think what we do at the DFEM stage, the design for additive manufacturing, is to totally minimize the whole post-processing, the need for post-processing, because 50% of the cost and the time lies in post-processing. So most of our designers try to minimize the amount of post-processing required beyond the normal annealing and YADM. Support structures, we try to minimize as much as we can. And we always tell our designers and the customers it's a compromise between performance and post-processing, manufacturability. So you can take a little bit of a hit in performance improvements, but you improve the whole manufacturability and the whole production life cycle. So that helps with the economic part of the whole equation.
Mm-hmm. Do you have anything to add to that, Luzen?
I think I do agree with Benjamin. I think the aim for AM is really to minimize the post-processing. And actually, as I shared earlier, even right now with powder bed fusion, we are actually quite confident in achieving the density, which is 99.95, which means even the porosity may be only up to 0.05%, or even sometimes less than 0.001%, or 0.001%. So given such, with the feedback from the industry, it's actually quite good. And that's why for now, we actually spend limited effort in post-processing, but we do have lots of tools, but not software yet. Yeah. Thank you.
Mm-hmm. All right. Another question from Vipuru Krishnagowda. Would you explain a bit more on how digital transformation is going to improve AM productivity? Ben, maybe?
Yeah, the digital twin, I always look at it as remember the age of the film camera. Yeah, we go for a holiday, we take a photo, 2 weeks later we develop and realize we took a wrong photo. So the digital twin helps us to have an instant image of what it is today, and then we can optimize it. So having a feel of digitalization of the digital twin will help you improve your decision making quickly. So we can design the whole factory, virtual factory, or the virtual product with the assembly, and make the decision within 2 weeks. You don't have to wait for 3 months for the actual build to happen, and then test out the car. Yeah, so I think the digital twin helps us enhance the decision cycle and make the corrections, so that will be a one-time first build correct. Yeah.
Luzen, care to add to that?
Oh, sorry. Where?
Digital transformation.
Yeah. So actually, because right now for most of the OEM, the machine is working as individually. So basically, per machine is a unit. So actually, moving towards the future, the idea is about the factory of the AM machines. So we do have a few pioneer customers, mainly in Europe and North America. They are actually linking multiple machines together. So it's actually they can using digitalization to. It's also the next step and the preparation for mass production. So I think with this, they can achieve more productivity and efficiency. So I will say this is one small step for the adopters with AM machines to link machines together as a unit and a factory. And this factory concept will further accelerate your adoption in AM. Yeah, thank you.
All right, great. Thank you very much for that. Speaking of the future, maybe my last question is for David. What do you think will be the key areas of interest and the overriding development in 2021?
Yeah, I mean, I think at the start of 2020, I'd have said we wouldn't see great change, but I think now, as we reset to 2021, we'll see a wider choice of machines, materials, engineering software. I think that, as I mentioned, there'll be more competition. I think at the start of this year, and in my presentation, I talked about themes. We said that the big theme for this year would be sustainability. That obviously was put on hold when we had when the pandemic hit us. But I think there will be a drive for sustainability. I've noticed some comments about that. I think that will be important. And I think also in 2021, we've seen lots of interest around AI. And I think AI will be adopted more widely in various ways around sort of 3D printing. Perhaps in sort of using AI to recognize geometric shapes and materials. It's a developing area, but I think that's going to be particularly interesting, and obviously more materials. Perhaps greater use of sort of more product design and multi-materials, maybe things like ceramics and metals being combined in some way, shape, and form. So I think there'll be a lot of drive, a lot of pent-up demand, a lot of interest going ahead into 2021.
All right, great. Thank you very much for that, for your answers, Lucian, Benjamin, David, and for your presentation. Everyone, thank you all for joining us today in today's webinar, and then thank you for your patience. We hope you have learned about some of the key considerations and some of the 3D printing technologies that will help you on your additive manufacturing journey. Our presenters will just reach out to you if you have further questions. Thank you very much again, and see you in our second part of our webinar, the panel discussion on December 15. Again, thank you.
Thank you.
Thank you.
Cheers. Bye.
Bye-bye.
Bye.
Thank you. Bye.